We're going to do a video today on effective stress and pore water pressure. This is a maybe a second year, first year soils course. So you're going to do geotechnical engineering and civil engineering. And you're going to come across some questions like this where they're going to ask you to find the effective stress in a specific spot in a layer, different layers of sand and clay, and then later it'll get more complicated and you have to find the stress increase due to loads and stuff like that. But for now, they just want you to find the effective stress. Yeah, it's not too hard. It could be a little bit tricky, but let's just go through this question. So we have we're given a couple things. We're given the specific gravity of clay, and we're given the moisture content of clay, and we're asked to calculate the effective stress in the center of the clay layer. So this dotted line here. Okay, we're given some other stuff here. This is moist sand, and we're given the unit weight for the moist sand. We're given the submerged unit weight or the bulk unit weight of the sand, and this is the water table here at 2 meters, okay? And we're going to need to have to calculate gamma saturated, okay, for both the sand, because everything below the water table here is obviously saturated because this is the water table. So we're going to need to find gamma saturated for this. We're going to need to find gamma saturated for this, okay? So let's go ahead, and gamma saturated for the sand is easy. We'll start with that. Okay, we're just going to add 9.81, or gamma water. Okay, so let's go ahead and do that. So we have 20.31 for the gamma saturated. Okay, so this is always the first step when you're finding effective stresses, is find the unit weights that you need. Now let's find the, for the clay, let's come down here. We're going to need to use a couple formulas, okay? So when this degree of saturation is equal to 1, okay, that's, I guess, an assumption that we're going to make here because we're not given. The void ratio is equal to the water content times the specific gravity, okay? That's a formula. So you'll notice in these geotechnical courses, there's tons of little formulas like this. Tons of little formulas, okay? So, your professor will probably give you a formula sheet. Really, really study it well, because just using these tiny little formulas here, like for example, they might give you, specific gravity, they might give you moisture content, and you're going to need to know which formulas to use in order to find the void ratio, for example. And if you have to write a cheat sheet on your own formula sheet, you have to make sure that you include all these little formulas because they're really important. Okay, so we have the moisture content. Okay, it's 0.56. And we have the specific gravity. It's 2.75. And that should give us 1.54. So we have a void ratio of 1.54 in the clay. And now we're going to use the formula for gamma saturated for clay here, for the clay stratum. And that formula is simply, and this comes back again to the little formulas that you're going to need to include in your cheat sheet or be familiar with. There's tons of little formulas like this in geotechnical engineering. So we know gamma water, 9.81. GS is 2.75 plus 1.54 divided by 1 plus 1.54. Okay, we're going to get 16.57 for gamma saturated. For the clay. Okay, so now we can go ahead and we can start to solve for the effective stress, okay? And I'm going to give you the formula for effective stress, and we can talk about it, and then we can do it. So the effective stress formula, okay, which we're going to label as sigma prime, is equal to the total stress, okay, minus the pore water pressure. So that's designated by mu. We're going to call that mu W. Okay, so sigma T minus mu W. And so essentially the effective stress is the stress that causes the soil to deform. So it's an important thing to know in geotechnical engineering. This is the total stress caused by the water and the sand or the clay above it. And this, we have to subtract the pore water pressure, okay? Because if I draw a little picture here and pretend that these little things, or these little circles, are sand, what happens, okay, is the water that's trapped inside pushes outwards. I hope you can see that, but it's going to push out. It's going to counteract the effect of the stress and the deformation by pushing outwards, okay? That's why we subtract the pore water pressure from the total stress to get the effective stress, okay? And, okay, so what do? Well, this is how we find first total stress, okay? So total stress, what we're going to do is we're going to calculate to the clay layer in each layer the stresses, and then we're going to add them all together, okay? So right here, I'm going to say total stress is equal to, and all you have to do is make sure that you multiply the distance, the length of the layer, by the correct unit weight. Okay, so this is moist sand, we have gamma moist. So we're going to multiply 18.68 times 2 meters. Okay? And that would be the effective stress at the 2 meter mark. Now, sorry, the total stress at the 2 meter mark. Let's go down to the bottom of the sand. Now see how we have a water table here? We're not going to worry about that. We're going to calculate them separately, but keep that in mind, okay? So we're just calculating right now the total stress. And we're going to use gamma saturated for that. So we're going to add the 4 meter depth of the sand times the saturated unit weight, because as we can see, it's underwater now. This denotes the water table level. And finally, we have the halfway to the clay layer, okay, because they want us to the middle, so 4 meters in, okay, and we're going to have a 4 meter layer, and that's going to be multiplied by the saturated unit weight of clay, which is 16.57, which we calculated. Okay, and if we add that up, okay, we're going to get 184.88. Okay, so this is the total stress at this point right here, or any point along here, due to both the water and the sand and the clay above. Now we're going to have to subtract the effect that the water has, as I explained before with this diagram, and let's go ahead and calculate that. So we have mu water, okay, and it's just gamma water times the distance of the layer that's below the water table. So there's no saturated area here, so we're not going to include that, but we have a water table here, so we have to subtract. We have 4 right here, starting from here, going down to the sand, times 9.81 plus 4 times 9.81. And so we have 78.48 kilonewton per meter squared. That is mu W. And as I described before, we're just going to go ahead and apply this formula here. We're going to take the total stress and subtract it from the pore water pressure. And I'm just going to scroll down because I've just did that calculation ahead of time. And we have 184.88 minus, right, 184.88 is the total stress minus the pore water pressure, and that is equal to the effective stress. Okay, so the effective stress along the clay layer, the center of the clay layer, is 106.4 kilonewton per meter squared. Okay, so thanks for watching, guys. Much appreciated. I hope that explained to you a little bit at least how the effective pore water pressure affects the total stress, and you know how it takes away from it. Like and subscribe if you enjoyed the video. Thanks for watching.